right, guys, this is the third day of section 6.1. All we're going to do today is just practice more of this verifying identities process that we've been talking about together the last couple days. What I want you to do in class today is pause and restart the video. Maybe give yourself 3 or 4 minutes per problem. So if there's 2 of them on a slide, maybe 7 or 8 minutes for each slide. Try them on your own, and then when the majority of the class is ready, and you can see how I proved the identity. Remember, this is not the only. So if you have different work, that's something that you and I could always sit down for a couple days and I'll look over it. I'd be happy to tell you if it makes sense or not. But for right now, we'll just at least see one method for each of these. All right, so when you're ready, go ahead and pause the video. Start on these 2, give yourself 7 or 8 minutes, and then when you're ready, hit play and you can see the solutions. So my first thought when I see this is 1 over cotangent is the same as tangent, and 1 over tangent is the same as cotangent. And again, the whole thing is still equal to 4. Tangent plus tangent, like terms, put them together, that gives me 2 tangents. Cotangent plus cotangent, if I put those together, I get 2 cotangent. The whole thing is still equal to 4. 2 times 2 gives me 4, and then I have tangent, cotangent. Tangent and cotangent are reciprocals of one another, so if I multiply them together, I get 1, which means they are essentially going to cancel each other on this side. And then I have 4 equals 4, make my nice little box. My identity is proved. Looking at the second one, probably going to be using Pythagorean identities here. This is one that I would probably work on both sides as well. I think I'm going to use the Pythagorean identities because I see those squares, secant and cosecant. Those are related to tangent and cotangent, so that might be a little helpful if I can get those all in the equation. So secant squared, our Pythagorean identity says that's the same as 1 plus tangent squared. So we'll do that on both sides. And cosecant squared, that's the same as 1 plus cotangent squared. And again, I'll do that on both sides. Over here I have a plus between them. Here they are multiplied. Here we go. On the left side, it's addition between the parentheses, so all I can do are add together like terms. So I have 1 and 1 gives me 2 plus tangent squared plus cotangent squared. On the right side, they're multiplied, so you can go ahead and FOIL. My first terms, 1 and 1, will give me 1. My outside terms will give me cotangent squared. My inside terms will give me tangent squared, and my last terms will give me cotangent squared, tangent squared. On the right side now, I have this term at the end, cotangent squared, tangent squared. Again, cotangent and tangent are reciprocals of one another, so if I multiply them together, I get 1. So now on this side, I have 1 plus cotangent squared plus tangent squared plus 1. And then if I combine my 1's together, I get 2 plus cotangent squared plus tangent squared, which is what I have on the left side, so I have proved my identity. When you're ready, go ahead and flip or continue to play. It will flip to the next slide, pause it, try it on your own, and then you'll see my solution. Okay, the first one should be pretty straightforward here. We're just FOILing sine plus cosine squared. First term will give me sine squared. My outside terms are sine cosine. My inside terms are sine cosine. And then my last term will give me a cosine squared. Combining like terms together, I have a sine squared, a cosine squared, And then I have sine cosine, that gives me 2 sine cosine, which you can see is what we see on that other side, so that's a good term to show up. And then if you recognize sine squared plus cosine squared, that's our Pythagorean identity, that is equal to 1. And so if I replace that now, I see the same thing I have on the right, and I have my identity. All right, the guy on the right side, I'm going to do a little factoring here. Definitely working on the more complicated side on the left side. I'm going to factor a sine out of my numerator. That will leave me with 1 minus 2 sine squared. Denominator, I have a cosine you can factor out. That would leave me with 2 cosine squared minus 1 equals still tangent on that other side. Now you can split this into 2 fractions. You can think of it like sine over cosine times what I see in those parentheses. Sine over cosine, because this is all multiplied products, I can go ahead and simplify that. That is the same as if we think about our quotient identity, tangent. And then I still have 1 minus 2 sine squared over 2 cosine squared minus 1. So if you're comparing sides now, I have that tangent I want. So now the goal that you need to keep in mind is we want to be able to cancel what we see in this fraction. Numerator and denominator, if I can get those to cancel, I will have tangent times 1, which will give me the tangent I'm looking for on the other side. To get something to cancel, they need to look the same. They need to be a common factor. So we either need to make the numerator look like the denominator or the denominator look like the numerator. I'm going to work in my numerator. Sine squared is the problem here. I want things in terms of cosine if I want it to cancel. So this is where we use an alternate version of our Pythagorean identity. Pythagorean identity, I'll do it on the side here. The original one is sine squared plus cosine squared equals 1. So if I'm looking to see what sine squared is equal to, I can just subtract cosine squared to the other side of the equation. So sine squared is equal to 1 minus cosine squared. And that's what I'm going to use in my identity over here. So bringing everything down, tangent times my numerator, 1 minus 2, and then instead of sine squared, we're replacing it with 1 minus cosine squared. And you could do that in the denominator as well. You could replace cosine squared with 1 minus sine squared. That's an alternate way to do this. Denominator, I'm going to keep the same. I'm going to simplify. I need to take this negative 2 and distribute it in. So I have tangent times 1 minus 2 plus 2 cosine squared. Denominator is still the same. And now I have these like terms, 1 minus 2, which will give me negative 1 if I put those together. So now in my numerator, I have 2 cosine squared, and then that 1 minus 2 gives me minus 1. Denominator already is 2 cosine squared minus 1. So now I have the same numerator and denominator, which means they will cancel, and I have tangent times 1, which is equal to tangent. On the other side, I have tangent, and I have proved my identity. When you're ready, let the video continue to play. Try the next 2 problems. Pause while you're working, and then hit play when you're ready to see the solution. This first one is a great example of when you might want to use sines and cosines. We've got 4 different trig functions here. Pretty hard to combine and relate things to one another when there's so many different ones. If we write everything in terms of sine and cosine, we take something that has 4 different trig functions and condense it down to 2 trig functions, and we have a lot more opportunities to simplify. So tangent, our quotient identity, is the same as sine over cosine. Cotangent is the same as cosine over sine. And on the other side, secant, same as 1 over cosine, and cosecant, the same as 1 over sine. On the right side, we can multiply them together, just multiplying straight across. My numerators give me 1, My denominators give me cosine sine. And you can see now I've got two fractions on the left. I have one fraction on the right. So the only way to get these equal to one another are to take these two fractions and make them equal fractions. So add them together. Or vice versa. You could split fraction on the right. That's a little bit more difficult of a method to use. We know if we want to add fractions together, we need a common denominator. There is not a common denominator here. So we're going to go ahead and get one. It looks like I want cosine times sine. I need both a cosine and a sine here. So I'm going to multiply my first fraction by sine over sine, which remember that's just like multiplying it by 1, so it's not changing it. Or multiply the second fraction by cosine over cosine. Again, just like multiplying it by 1. So that's going to give me numerator of the first one, sine squared, and then denominator sine cosine, my denominator. The numerator of the second one, cosine squared, and then the denominator sine cosine. And now, because I have a common denominator, I can add them together. Sine cosine remains my denominator, and in the numerator I have sine squared plus cosine squared. And hopefully we all recognize that that is our Pythagorean identity. Sine squared plus cosine squared is equal to 1. So now I have 1 over sine cosine, which is the same as what I see on the other side. We know multiplication is commutative, so sine times cosine is the same as cosine times sine. And my identity is verified. The next problem, when we see this 1 plus, 1 minus situation, remember this is a good one to think about using a conjugate. You could use either a conjugate on the left or the right. If you tried to use a conjugate on both sides, you're going to notice you kind of undo some of your work. So just try on one side. Let's say I want to work on the left side. The conjugate of the denominator is 1 plus sine of t. 1 plus sine of t. And then I'm just going to simplify this side. In the numerator, I need to distribute my cosine. So cosine times 1 is cosine t, and then cosine times sine. Cosine t, sine t. Denominator, 1 plus sine. Remember, you are foiling just first and last. First, 1 times 1, 1. And last will be negative sine squared. Continuing to simplify a little bit, a couple things I notice I can do here. First thing I notice, in the numerator, I can factor out a cosine. They have that in common. That leaves me with 1 plus sine t, which actually I guess that's what I had to start with. I maybe shouldn't have distributed that in to begin with, but that's okay. In the denominator, if we're comparing what we have on the right side to this guy, we don't want sines in the denominator, we want cosines in the denominator. And hopefully you recognize we did this on the last slide, 1 minus sine squared, that's an alternate version of our Pythagorean identity, equal to cosine squared. And now I have a common factor of the numerator, cosine is a factor of the denominator, so 1 of my over cosine t, which is what I have on the other side, and my identity is verified. All right, last identity we're going to prove in this lesson, this guy. Again, we see this plus minus situation happening. Also, if we think about what we're seeing here, secant and tangent, cosecant and cotangent, those are related to one another with the Pythagorean identity. We can't use that yet because it's not squared. So again, conjugates in this problem are going to help. If I use the conjugate of the denominator, first fraction would be cosecant minus cotangent. And the same thing on the top is going to have to be multiplied in. For my second one, same idea. I'm going to use the conjugate. All right, and I'm just going to deal with that left side right now. I'm not going to worry about the right side just yet. So So I've got some foiling in both of these that I'm going to need to do. Denominators, I've got conjugates. And for the first one, I'm going to be left with cosecant squared minus cotangent squared. And for the second one, I'm actually going to, not only did I get the squareds that I wanted here, I also got a common denominator, which is helpful. In the numerator, you are foiling. So we're going to have some work here. These are not conjugates. So you're going to have to get out all 4 terms. So cosecant times secant are my first term. Hold that thought. Okay, I'm back. All right, so where was I? First term, cosecant times secant. Then I have my outside terms, cosecant times tangent. Then I have my inside terms. I'm going to run out of room, so I'm going to try to squeeze these all in the numerator here. My inside terms are negative cotangent secant, and my last terms are negative cotangent and tangent. I'm going to do the same thing in this second fraction. Secant, cosecant are my first term. My outside terms are secant and cotangent. My inside terms are negative tangent, cosecant, and my last terms are negative cotangent and tangent. All right, now because we have a common denominator, we can put these fractions together. My denominator will remain cosecant squared minus cotangent squared. I'm going to combine my numerators together. Be careful here. They are subtracted. That negative applies to the entire fraction. So when we're looking for these like terms, things that I can put together, remember we want to insert a negative in front of all those terms on the other side. You could even do that now if you want to. You could change this to a plus and then distribute a negative through. So negative, negative, positive, positive, if that's maybe a little bit easier to see. All right, so let's go through our like terms. I have a cosecant secant and a negative secant cosecant. They actually cancel. What else do I have? I have a cosecant tangent and another cosecant tangent. So that gives me 2 cosecant tangents. I have a negative cotangent tangent and a positive cotangent tangent. They cancel. And then my last 2 terms, again, are like terms. They're both negative here. So it's going to give me a negative 2 secant cotangent. Okay. Let's see where we can go. I've still got quite a bit going on. I've got a lot of different trig functions here right now. I'm going to go ahead and use my sines and cosines at this point. If you wanted to, we know we want that 2 on the other side. You could factor a 2 out at this point and just deal with what's left. My numerator, cosecant tangent minus secant cotangent. In my denominator, cosecant squared minus cotangent squared. And actually, before I do sines and cosines, let's deal with that denominator. I didn't notice this earlier. Cosecant squared minus cotangent squared. Those are related in a Pythagorean identity. I'm going to make that off to the side here. My Pythagorean identity is 1 plus cotangent squared equals cosecant squared. So if I move cotangent squared to the other side, I have 1 is equal to cosecant squared minus cotangent squared. So this is even better. These guys are just going to equal 1. So my denominator is essentially gone. So I have 2 times cosecant tangent minus secant cotangent. All right, let's do our sines and cosines now. 2 cosecant is 1 over sine, and tangent is sine over cosine. Minus secant is 1 over cosine times cotangent, which is cosine over sine. So if I multiply these together, the first fraction, I'm going to have a sine and a sine. I'm going to be left with 1 over cosine. Second one, I'm going to have a cosine on the top, cosine on the bottom. They cancel. 1 over sine. And then these are our reciprocal identities. I am left with 2. 1 over cosine is the same as secant. 1 over sine is the same as cosecant. And now if we look way back up at the top, what we started with on the other side was 2, and then quantity secant minus cosecant. So bring that down. And whew, that was a tough one. We have proved the identity. Last set of problems for today, if you have a little bit of extra time. I've got 5 problems on here that are common mistakes that are made. The biggest mistake people make is factoring, but honestly, it's just algebra rules that people mess up on most often. So pause the video, take a couple minutes, and see if you can figure out the mistake that happened here. When you're ready, go ahead and hit play, and we'll talk about just these common mistakes, misconceptions, and we don't want to make these because if you make an algebraic mistake as you're proving, something that is verifiable, able to be proved, will no longer be able to be proved. So you get yourself in kind of a pickle when these little mistakes occur. All right, so pause the video, see if you can find the mistake, identify the mistake, and then play it when you're ready, and I will walk through it with you. All right, first mistake in number 1, they canceled a cosine. You may not cancel a cosine or any other term unless it is a common factor throughout. So if you want to get a cosine to cancel, you would first, in this problem, need to be able to factor a cosine out of the numerator. Because all terms in the numerator do not have a cosine in them, it does not cancel. Second problem, they added the fractions together, but they did not have a common denominator. Right now we have sine over 1. 1 and cosine are not common denominators. If you wanted to attempt to add these together, you would first need to, for this first fraction, multiply by cosine over cosine. Get that common denominator of cosine, and then combine them together. Third problem, the mistake is they distributed the squared through. We know that's a big no-no. What you actually need to do here is FOIL. So tangent squared and cotangent squared are your first and your last terms, but the outside and the inside are missing. So there'll be, again, a mistake as you're working through, and it won't be able to be proved if you miss those terms. Number 4, really you kind of have to get into the head of the person that did this problem. They attempted to take the square root. A square root operation is something that you must do to both sides of an equation to keep it balanced, and we know when we have an identity, we can only work on one side or the other, so that's definitely a no-no. Another issue that shows up here is if you think about taking the square root of something squared, that's fine, but if we have addition or subtraction, you cannot simplify. So again, that balancing, we need to do the same thing, is a no-no. Last one, number 5, they just so that 2 on the bottom should be gone. All right, that's the end of the 6-1 lesson. If you guys have questions about any of this, you can let me know when I get back. You could also just watch the video again on YouTube if you need to. Here are the homework problems that I showed you earlier. Homework quiz that's coming up. Let me grab my calendar and I will give you the date of that. Give me 1 second. Homework quiz is coming up Monday. Need to make sure these, as well as the ones from section 6.2 that we're going to do over the next couple days, are completed and ready to go by the 12th. And then just as a reminder, the trigonometric, that is going to be March 20th. But you can always start looking over those, make some flashcards, get a couple down at a time, and as we continue to add them in, you can add more flashcards to your list and be ready by the time it comes around. You have a couple weeks for that. All right, that's the end of our lesson. Whatever time you guys have left in the period, you can work on your homework.